Hello everyone, once again welcome back to the Chem School. Now if you remember, we have almost completed with IUPAC nomenclature of the coordination compounds, and today is a practice day. Okay, so here I have given you some examples. Without looking at the solutions, what you will do is you will start writing down the answers for each of them. Okay, so start writing down the IUPAC nomenclature on your own. For now, okay, I'm solving all of them. So let's start. Now have a look at the first one. Usually when you have seen this complex, you will just see it as LiAlH4. Okay, the bracket, very few people use for this one, that is lithium aluminum hydride. Okay, so lithium aluminum hydride is a common name. Okay, let's write down the IUPAC nomenclature for this, okay, reducing complex. So here the name will be, first one is lithium. Okay, then the ligand is H minus, that is hydride. It is 4, so tetrahydride. Okay, so it is hydride, for anionic ligand, the E will be replaced by O. So tetrahydrido. Okay, then you have aluminium. Now you should remember that if it is an anionic ligand, it will end with 8. The metal name will end with 8. So aluminium will become aluminate. Okay, so just remember that. So tetrahydrido, aluminate, and then the oxidation state. Okay, so -4, okay, and +1, so that is -3. It goes on the other side of equal to, so that is +3. So the charge on the aluminium will be +3. Okay, write down the oxidation state in Roman numbers. So this is how your IUPAC nomenclature will look like. Okay, so if you want, you can calculate the oxidation state before, if it is difficult for you to calculate in mind. Okay, the next one, again cation, you will write down only once. So sodium, just sodium, do not write down disodium. Okay, that's a mistake, that's a blunder. Fine. Next, here you have chlorido, okay, or chloro, anything that you like. So 4-chloro, so you will say it is tetrachloro. Okay, again it is only an anionic ligand. If there is only an anionic ligand, you will have the metal name ending with 8. But let's say you have at least one neutral ligand, then the metal name will remain the same. Zinc remains zinc, aluminum remains aluminium, cobalt remains cobalt. Okay, so for now you will say it is zincate. Okay, so tetrachlorozincate, because you have only anionic ligands. Okay, next, oxidation state, this is +2, -4 is -2 on the other side of the equal to. If it goes, it becomes +2, so the charge of zinc is 2. Okay, the oxidation number will be 2. Next, potassium. Okay, then this is oxalato. So you have 3 oxalato, so tris oxalato. Okay, then you have aluminium. Okay, again oxalato is an anionic ligand. Okay, so you have only an anionic ligand, so you will not write down aluminium, you will have to write down aluminate. Okay, so aluminate, oxidation state, the charge of oxalato is -2. Okay, the charge on oxalato is -2, so -2 into 3, -6, -6 plus 3, that becomes -3 left on the other side of equal to, so only 3 left. Is this clear? One other thing that I want to say is, if you have an anionic ligand, okay, instead of writing down bis, tris, tetrakis, you can also use bi or di, tri, tetra. Okay, both the name is accepted, so you have to check the MCQs accordingly. So the other name for this can be, you can also see in many books, potassium trioxalato. Everything else will remain the same. Aluminate. Okay, and oxidation state of the metal will be 3. Okay, next one. So here you have amine, so 6 ammonia, so 6 amine, so hexamine. Okay, so here you have hexamine. If you want, some books you can see 2 times A written, so we'll write down hexamine. Okay, you can remove the vowel as well, your choice. So hexamine cobalt. Okay, because it is a neutral ligand, so only cobalt, not cobaltate. Write down the oxidation state of the metal. Okay, so neutral ligand, it is 0. You have anionic ligand -3. On the other side, +3. So cobalt 3. Then it is Cl, so you will write down chloride. Anything outside the square bracket, do not forget to write it only once. No di, tri, tetra for them. Okay, next one. So here you have two ligands, that is chloro and ethylene diamine. Okay, so follow the alphabetical order. So first chloro, so dichloro, ethylene diamine is a neutral ligand, so bis ethylene diamine. Okay, then you have cobalt. Find out the oxidation number of cobalt. Okay, so this is -2, this will be 0, so -2 is equal to, look at the charge over here, is +1. Okay, so here if you see, it is going to be cobalt 2 into -1. Okay, this is going to be 0, is equal to, on the other side you will have charge of +1. Okay, so that is what I meant to say, that you have to look at the charge which is present on top of the square bracket. So now you will have charge of cobalt which is equal to -2 goes on that side, +2 and +1. So total charge on the cobalt will be +3. So this is how I have calculated the oxidation state. Once again I am showing you that. So write down the oxidation state in Roman number. So that is 3. And if you have charge above, so after Roman number you will write down ion. Whether it is cation or anion does not matter. You will just write down it is ion. Okay, so this is again one more example of a different type. So have a look at all of them. If you have any doubt, do ask me in the comment box. Let's solve some more examples after this. Now, these are some other examples you can solve from 6th to 9th on your own. Okay, I have already given the solution for that. If you still have any doubt, do ask me in the comment box. But let's have a look at the last one, that is 10th one. Now, if they draw the structure, okay, of the complex, something like that, you can see there is only one metal, that is cobalt, and you can see that the structure is drawn, which gives you one clear indication whether it is cis or trans. Okay, we will talk about isomerism and coordination compound. At that time this will become very clear, but for now it will be a bit different, but it is not difficult. So you can see, you already know the concept that if they exist on the same side, it is cis, on the opposite side it is trans. So you can say that En is on the opposite side. Okay, and you can see again NO2 is on the opposite side. Yes or no, right? Because of that you will say that they are trans complexes. So in the name you have to include that. So this is trans, so start with that. Okay, after trans, find out the alphabetical order and write down the name of the complex. So ethylene diamine starts with E, then nitrito, okay, starts with N. Now, or you can say nitro, it starts with N. Now in this case, we will write down ethylene diamine first, and because it is, you know, a chelate, you will use bis because it is 2 times. So trans, then you will say bis ethylene diamines. Many books you can see double M written. Okay, so bis ethylene diamine, then you have 2 nitro, so dinitro. Then you will talk about the metal, that is cobalt. Now you can see that in nitro N is attached to the metal. Okay, so you will say it is N. Okay, after this nitrogen is attached to the metal, so you will say it is N. Then after that, cobalt oxidation state, find out. Okay, so this is neutral. Nitro will have a charge of -1 each, so -1 that is -2. Okay, and Cl will have charge 1, that is -3, equal to, if it goes on the other side it becomes +3, so cobalt will have a charge of 3. Okay, then you have 1 chloride. So it was just that they have drawn the structure, there is nothing more in that. Okay, just one extra concept was included, that you have to say whether it is cis or trans. So if 2 ethylene diamine lies on the same side, you will say it is cis. If they are lying on the opposite side, you will say it is trans. Okay, the nitro is also on the opposite side. You can see this very clearly. Okay, so this is a trans complex, and the name is as we used to write for this one. Okay, one more thing I would like to talk about, like you have said that because the metal is attached to nitrogen, you will say it is N-cobaltate. Similarly, there's one more complex I have included. HCN is thiocyanide. Okay, now you can see that platinum and sulfur, you can see which are close to each other. So you have to indicate when it is written in this form that sulfur and platinum is having coordinate bond. Okay, therefore before platinum you will say sulfur is attached to platinum, that is platinate. Okay, so we do indicate that in many complexes to which metal. Okay, if you have ambidentate ligands, then you do specify to which metal it is attached. Okay, from which element. So that was all for the day. I hope you are very clear with this. See you soon in the next class. Thank you.